Hello guys, welcome back to your favorite and India's most affordable learning platform, Physics Wallah. So in the last session we have started the rotational motion chapter. Already 2 lectures are completed, so it's the third lecture. So we are discussing about the basics of the rotational motion. In the first class we discussed about the angular terms, right, and we compared them with the linear terms. And then in the last class we understood what is the static equilibrium, so how do we apply the torque, so right, so that also we discussed in the last class. So in today's session, so I am going to discuss the moment of inertia introduction and some concepts related to that, and moment of inertia of system of particles and continuous mass distribution, and there will be some standard formulas which you have to remember. So I'll give those formulas in the tabular column tomorrow. So today we'll understand just the moment of inertia and how do we find the moment of inertia for the system of particles and for the continuous mass distribution basics. So and for all the other objects like cylinder, cone, disc, ring, for all these we have to find the moment of inertia. So that I'll give it in the tabular column tomorrow. Clear? Chalo. So hope you guys are understanding the classes. So I just need your attention for the next 1 hour. Avoid all the disturbances around you guys. If you have any doubt, just mention it in the comment. I'll definitely take that doubt. Okay. So at the end of the lecture, it's very important to prepare your own short notes. Okay. Chalo. So let's begin the today's session, guys. So I gave some homework in the last session. So let's start with the homework questions first. I'll solve these, then I'll move on to the today's topic. So see here. So what's the topic says? So let me just have a minute. Yeah. So what's the question says, guys? Here, ABC is an equilateral triangle. So with O as its center. So F1 and F2, F3 represents the forces acting along the sides AB, BC, AC respectively. So this is an equilateral triangle and there are 3 forces. F1 force along AB, F2 force along BC and F3 force along AC. So and if the total torque about O is 0, so the torque about O is given 0. So then the magnitude of F3 will be, see here. So first thing is identify what are the forces acting. So this side the force F1 is acting, and here the force F2 is acting, and here this side so the force F3 is acting. Yes or no? Now see here. So the torque about O is given 0. So the torque about O is given 0. So the torque about O is due to all these 3 forces. So the first force will be at a distance, this one. So the second force, let's suppose this is X. So this also will be X. So the third force also will be X, because this is exactly at the center of the equilateral triangle. So this center distance from all the sides will be equal, right? Yes or no? So now, so the torque about O. So which, this one, the force F1 causes the torque this side. Yes or no? Just imagine. So this is your axis of rotation and you are applying the force this side. Just pull it with the rope like this. So then it causes the torque like this. And then so F2 about this point, if you pull it this side, so then it causes the torque this side. And then so about this point you are applying the F3 this side, so just pull the rope like this, so then it causes the torque like this. Yes or no? So the torque anti-clockwise will be equals to the torque clockwise, because the total torque about O is 0. So I can say that here. So what is the torque anti-clockwise? So the anti-clockwise torque is F1, force F1 into how much distance it is, X distance, and then plus, so the torque F2 into, so how much distance it is, X distance, right? These two are anti-clockwise. And then clockwise we have F3 force, which is F3 into how much distance it is from the center, X distance. So I can cancel X, X, X. So therefore, so the F1 is F1 plus F2 is equals to, so the force F3. So this is the relation between the forces, the 3 given forces. Simple question. Okay. So what is the magnitude of F3 they are asking? Magnitude of F3 will be F1 plus F2. So the magnitude of F1 plus magnitude of F2. Simple question. Chalo guys, let's move further. So let's take one more question. So what's the question says? A block of height h is projected along a rough surface of coefficient of friction mu. A block of height h. So this is a block of height. Total height is h. Fine. So now, so it is height h is projected along a rough surface. So this is a rough surface. This surface is rough. So coefficient of friction mu. So mu is a coefficient of friction. So the point of application of the normal force. See, one thing is the normal do not passes through the center. Remember it, guys. So most of the students think that normal passes through the center. So if you take the torque about the center, so the torque due to normal will be 0. No, the torque due to normal will not be 0. The torque will, normal will not pass through the center. Okay. So in this particular case, you just observe. So its weight will act along the center of mass. The weight, it acts at its center, right? Center of the body. And then, so as the body is moving right side, so as it is a rough surface, so the friction acts to the left side. Friction acts to the left side. And then normal upside. And what are all the other forces? So there are no other forces, right? So that means, see here. So about this point, we need the torque. So just imagine this is your axis of rotation. So then you are applying the force this side. So which causes the friction causes the torque this side. Yes or no? About this point. So you are applying the friction force this side. So then the torque causes this side. Yes or no? Similarly, about the torque due to normal. So the torque due to normal. So this is the axis of rotation and you are applying the force this side. Just imagine you are pulling it with a rope. So then it causes a torque like this. The normal causes a torque like this, right? So I can say that the torque due to normal will be equals to the torque due to friction. Simple logic. The torque due to normal will be equals to the torque due to friction, or else you can say that the torque due to normal friction is equals to 0, as it is the this is anti-clockwise positive and this is clockwise negative, so they both cancel like signs. So here, so I can write like what is the torque due to normal. So the torque due to normal, so one is the normal force into what is the force? Normal force into, so at what distance it is acting? X, right? And so what is this one? Torque due to friction. So the friction force is acting this side. So friction force into, so what is the distance from the center of mass? The friction is acting at a distance. So this will be h by 2. This will be exactly half, right? So this will be h by 2. So what do we need actually? The point of application of the normal force x is equals to. So we have to find this x. So I can write n into x is equals to, in place of friction, so as it is, coefficient of friction is given mu, so that mu into n is the f, so which is equals to n into h by 2. So n cancel, so therefore x is equals to, so mu into h by 2. So this is a place where, so the normal reaction will act. So but that means normal will not act exactly at the center, guys. Normal will not pass through the center. So it will act at a distance mu h by 2. So if the block height is given and coefficient of friction is given, so you can calculate, so at what distance the normal reaction is acting. Understood now? Clear? Chalo, important concept plus question. So you should understand the standard, you should remember it as a standard result. Remember it as the standard result. Clear, guys? Chalo. So let's move further. Chalo. So let's go for the next question. So the question number 3. So what's the question says here? A cubical block of mass m and edge A slide down a rough inclined plane of angle of inclination theta. Okay, so with the uniform speed. So the torque of the normal force acting on the block about its center. See here. So first imagine, so there is a inclined plane. So this is an inclined plane. So with an angle theta. So and then there is a cubical block which is placed here. So here is some cubical block. So whose side is A. So each side of the cube is A. Okay. So then, so it slides down a rough inclined plane. So this is a rough inclined plane. So let's its coefficient of friction, so mu. So theta with a uniform speed, so it is moving with uniform speed. So now we know that its weight acts downside, so its weight mg will act this side, and then this weight will have two components, one is this side, the other one is this side. So this side component, it will be obviously along the inclined plane, will be having mg sin theta, and this is mg cos theta, right? So now the normal will not pass through the center. Let's suppose this is the center of the body, so the normal will be at a distance, some x distance. We already know what is the distance also, right? So this distance x. So now this is a normal. So as it is a rough inclined plane, we know that the friction will be this side. So the friction, because the body is sliding with uniform speed, with constant speed, the body is sliding. So then, so the friction will act upside. Yes or no? So understood what are all the forces acting on the body now? So now you observe, I can say that the torque due to, so this force will be 0, mg cos theta will be 0. So the torque due to friction will be equals to the torque due to normal. So friction will cause the force this side, and torque normal will cause the torque this side. Yes or no? So the torque due to friction will be equals to the torque due to normal. Yes or no? So what they are asking, the torque of the normal force. So the torque of the normal force will be equals to the torque of the friction, right? So friction torque, you can just find the torque due to friction. What is the torque due to friction? So the frictional force is F, and at what height it is acting? So the frictional force is acting at a distance. So the its length is A. So it's half. So A by 2. So F into A by 2. So the friction, see here important point is, so what is the friction? Sorry guys. So here, what is the frictional force? So the body is moving with the uniform speed. If the body is moving with the uniform speed, so the friction will be balanced by its mg sin theta. The friction will be balanced by mg sin theta. So therefore, I am writing in place of friction, so mg sin theta into A by 2. So therefore, the torque due to normal will be equals to, so half into A mg sin theta into A. Half into mg sin theta into A is the correct answer. So check the options. So half into mg sin theta into A also should be there. So put the option A, 1, because everywhere A is there, so A should be there because the cube side is A length. Clear guys? Understood this question? Chalo. So next. So now let's come to the ladder problems. So here in these questions, so first thing, what are all the forces acting? So a ladder is placed, so against a vertical wall and supporting with the horizontal wall. This is a horizontal surface and this is a vertical surface. So I can say that let the ladder has some mass m, so that its total weight, so mg will act downward like this. Mg will act downward, and then so here point of contact is there, so normal 1 reaction act this side, and then so the normal 2 reaction acts this side, the normal 2 reaction acts this side. Yes or no? So and then, so next thing, what are the other forces? So as it consider this is a rough surface, and let's consider this vertical wall is also the rough surface. Okay, so now to which side the friction force will act? So understand clearly guys. So when you place a ladder like this against the wall, so then it tends to move this side. So that means the friction opposes the relative motion. So the frictional force F1 should act to the right. So the frictional force F1 should act to the right side. Yes or no? So and similarly here it tends with the vertical wall, so the ladder tends to come downward, right? So it moves downward. So that's why, so its frictional force should act upside here, so which is F2. So the frictional force will act upside here, right? So now see, we have got all the forces. So I can say that, so the net force acting on the body is 0. So the summation of the forces F net will be equals to 0. So if F net is equals to 0, what are all the forces that are acting on the body? What are all the forces that are acting on the body? Tell me. So N1 must be equals to mg. Here the N1 is balanced by mg, or else just don't take this. So if they mention it in the question, we'll take that. So you can take torque about just the torque and net force you can consider. So just don't write anything, we'll take the question so that you'll understand better. So these are all the forces which are acting on the body. Done, guys? So now let me take the question. See, what's the question says here? A uniform ladder of mass 10 kg leans against a smooth vertical wall. So the vertical wall is smooth, means there is no friction. So consider there is a vertical wall So a uniform ladder of mass 10 kg leans against a smooth vertical wall, making an angle 53 degrees with it. So here I am taking the horizontal surface. Here this horizontal surface is rough. This is smooth and this one is rough surface. Okay. So then a ladder is placed. A ladder is leaning against this. This is a ladder. Consider. Consider this is a ladder. So now the ladder mass is 10 kg, so that its weight 10 g will act downward. The first thing, its weight 10 g will act downward. So the ladder is making 53 degrees with the vertical. So if this angle is 53, obviously this angle will become 37 degrees. This angle will become 37 degrees. Fine. So next, what else is given? So find the normal force and the frictional force that the floor exerts on the ladder. So what is the normal force? The normal N1, let's suppose this one, and normal N2, this one. Yes, and then so the friction force here, the friction force will act this side. The friction force will act this side. So we have to find, so what is N1 and what is friction force F. So first thing is, so the simple logic, so let the net force be 0. F net is equals to 0. So if F net is equals to 0, what are the forces that are acting? Vertical forces. So summation of forces in the x direction should be 0. So the summation of forces in the x direction should be 0. So in the x direction, friction is acting right side, normal is acting left side. So the friction N2 will be equals to F. So the N2 will be equals to F. And then so take summation of forces in the y direction 0, sigma y 0. So then N1 will be balanced by 10g. N1 will be balanced by 10g. So which is nothing but N1 is equals to 10 into 10, which is 100 newtons. So directly you can find, so the what is the normal force? The first option 100, 100, 100, 100. So you can't eliminate any option. So directly you should go for the second one. So now you have to find the frictional force. So for the frictional force, I am going to take, so the torque about, let this be point A. Let this be point A. So let's take the torque about this point. Let's take the torque about this point. Sir, if you take about this point, so the friction will be, the torque due to friction will be equals to 0. Because the frictional force is passing through the, this is your axis of rotation. The frictional force is passing through the axis of rotation. So then the torque due to friction will become 0 now. So then we are finding torque due to friction only now, sir. So we can put 0, but there is no 0 option. See, the torque due to friction and torque due to normal both are same, because N2 is equals to F, right? So if I take the axis of rotation here, so I'll find the torque due to normal 2. Normal 2 torque I'll find. So which is nothing but torque due to friction. So no. So the torque due to N2 will be equals to the torque due to friction simply. Yes, because N2 will be equals to F. So now from here, so let me take the torque about, so the point A is 0. Let me take, so what is the, let me take this template, guys. So which one we have? This one, yeah. So see here, the torque about point A is equals to 0. So then torque about any point you can take it 0, right? Because it is in static equilibrium. So then the torque due to normal one will be 0. The torque due to friction will be 0. But the torque will be there due to 10G force. So the torque will be there due to 10G force. So 10G force is at a distance how much? So the 10G force is acting downward. So I am writing this side. So the torque due to the torque about A will be equals to, so I can write first thing. So about this point, right? So if you pull it downward, so which torque it causes? So it causes the torque this side. Yes or no? About this point, if you pull it downward, so it causes the torque this side. So what is this side torque? Clockwise torque. And then, so what about N2? So if you pull this side, about this point, if you pull the ladder this side, so then it causes a torque like this. So which is nothing but anti-clockwise torque. So then simply substitute the values. So the torque about point A is 0 means the torque clockwise is equals to the torque anti-clockwise, right? So the torque due to 10G force first. So force is 10G into, so what is the perpendicular distance? What is from here to here the perpendicular distance? So I can take like, so the total distance of the ladder is given no. So let the 10 kg and the smooth vertical wall. So let the total distance of the ladder be L, so that, so it will be L by 2 sine 37. So this distance, what will be this distance? Or else let's take the total ladder distance as 2L. Let's take the total ladder distance as 2L. So then it will be L and it will be L. So now I can take like, so this L, this side component it will be L cos 37, L. So theta is there this side. So this component will be L cos 37. So I am writing 10G into L cos 37 is equals to, so the torque due to N2. So the torque due to N2 will be N2 into force is N2. So into what is the distance? The N2 will be at a distance. So this will be the distance, total distance. So what will be this total distance? This is 2L and then this angle is 37. So I can say that 2L sine 37. This is total length is 2L. So this angle is 37 degrees. So obviously its perpendicular component will come. So this side L sine 37. So its perpendicular component will come here. 2L sine 37. 2L sine 37. Understanding guys? Clear? Right? So chal. So then here L gets cancelled. So from here 10 into 10 cos 37. So 37 adjacent, which is 4 by 5 is equals to, so N2, the torque due to N2 we have to find, and then here 2 into sine 37, opposite 3 by hypotenuse 5. So from here 5 ones are, 5 twos are, right? So then 2 gets cancelled. So then what else is left? So here we have, send this 5 to this side, 10 into 5 50, 50 into 4 200. So 200 by 3. So 200 by 3 means, so check the closest option we have. So 66 point, yes or no? So this comes out to be, so 3 6 are, so 3 6 are, and again 66.666 like that we'll get. So which is nothing but, so 66.6 newtons this one, and 100 newtons is the normal N1. Clear? Understood the concept guys? Just you have to take care of taking the perpendicular distance. So this distance will be, if it is from here to here it is L, so its perpendicular component L cos 37, and here the total distance is 2L. This one is total 2L and this angle is 37. So its perpendicular component what it will be? So 2L sine 37. So that's what I took. Clear? Understood guys? Chal. So now let's go for the next concept, that is moment of inertia. So moment of inertia is denoted with I. I is moment of inertia. It is denoted with I. So and it plays the same role as the mass plays in the linear motion. So whatever the role that the mass plays in the linear motion, so the same role, so the moment of inertia plays here. Moment of inertia plays the same role in rotational motion as the mass plays in the linear motion. So it is a property of a body due to which it opposes any change in the state of rest or uniform rotation. You have already studied in the grade 9th. So inertia of rest, inertia of motion, inertia of direction. Yes. So the same thing we are going to see it here. So it's, what is this? It's a property of the body due to which it opposes any change in the state of rest or uniform rotation. Here we are going to talk in terms of rotation only. So, and here one more thing, it's a scalar quantity. It's a scalar quantity. Okay. And what are its units? What is its formula, sir? First, so I is equals to moment of inertia is equals to m into r square. I is equals to m into r square. So what are its units, sir? So the units will be, so mass is in kg, r square in meters. So kg meter square r. So we can also write it as gram per centimeter square. So no need. So let's take then. So what are the dimensional formula for this? So what's the dimensional formula? So dimensions kg is m, and m square, L, meter square is nothing but L square. So the dimensional formula of moment of inertia is ml square. Clear? So now see here, guys, this is, see you about which axis you are finding the moment of inertia is very important. So in this particular case, so I am finding moment of inertia about this axis, x dash axis. So which is equals to, so of this mass I am finding m into, it is at a distance r, so m r square. So the moment of inertia about x dash axis for this particular mass will be m r square. Okay, about which axis you are finding, it's very important. From that axis you have to take the perpendicular distance. You have to take the perpendicular distance. Clear? Chalo. So if it is one mass is there, so simply we can write, so the moment of inertia about x dash is half m1 r m r square. So but if the system of particles, the moment of inertia due to system of particles, so about this axis I have to find the moment of inertia now. So about x dash I have to find the moment of inertia. So previously we attached only one mass to this x dash rotation. So now here we have different masses, m1 is there, m2 is there, and m3 is there, so which are at different distances. So I can write the moment of inertia as it is a scalar quantity. You can simply add the moment of inertia of all the bodies. So the moment of inertia due to m1, so which is let me write I1 plus I2 plus I3. The moment of inertia due to m1 body is I1, moment of inertia of m2 body is I2, moment of inertia of m3 body is I3. So then I can write, so the first one the first one mass is m1, so it's at a distance r1, so m1 r1 square. Second one, its mass is m2, it is at a distance r2, so m2 r2 square. And the third one, so which is at a distance m3, so then r3 square. Right? So this is a total moment of inertia. If any other masses are there, you can just add it up. That's it. So if there are n masses, plus till mn rn square, that's it. Because this is simply the scalar quantity. It's a scalar addition you can take. Clear, guys? Understood? Simple part. So let's move further. So let's take one simple question. So what's the question says here? 3 particles each of 10 grams are situated at the center, at the 3 corners of the equilateral triangle. So let me consider a equilateral triangle. So consider this is a, so equilateral triangle. So then here 10 grams and here 10 grams and here 10 grams mass is attached. So now determine the moment of inertia of this system. So about an axis passing through one of the corners of the triangle and perpendicular to the plane of the triangle. So let's consider the triangle is in this plane, and so your axis is passing through, just understand properly, guys. So the axis is passing through this one. The axis is passing through any one of the corner. So let me take the axis is passing through this corner and perpendicular to the plane of the triangle where lies. So the triangle is lying in this plane. This board is a plane now. So now I am passing a line here. So through one of the corners of the triangle. So now about this point, about this axis, I need, let's suppose this is x, x dash, this point is x and this point is x dash. So this x, x dash is passing through this corner. Okay, so now about this you have to find moment of inertia. So simply you understand that here axis is there, and from the axis, so here to here, what is the distance? This distance is from here to here. So the distance they gave 5 centimeters. So this distance is 5 centimeters, and this distance is how much? So here is also, this also 5 centimeters from the axis. So from the axis, so this distance is also 5 centimeters. So now simply the moment of inertia about, let me consider that axis as x, x dash. So which will be equals to, so I can write, so due to 10 gram mass into, so the distance square, what is the distance? 5 centimeters. So let me write, so it is in kg meter square is there, so convert everything guys. So the first mass is at a distance 5 centimeters, so 5 into 5 centimeter, 5 is the distance, so 10 grams, so mass is 10, so 10 by 1000 into 5 centimeter square, 5 square means 5 centimeter square, so which is 25, so centimeter square means, so I can write 10 to the power minus 4 meters, I am converting it. So then next we have, so the other one is also, so it is at a distance 5 centimeters again, so mass is 10 grams again, so 10 by 1000 into, so 5 square, 25 into 10 to the power minus 4. So what we can write here, so which is equals to here, 0 0 cancel, so this will be 10 to 25 into 10 to the power minus 6. So here also 0 0 cancel, so 25 into 10 to the power minus 6. So I can write 25 25 50 into 10 to the power minus 6, right? I am taking 10 to the power minus 6 common, so 50 10 to the power minus 6. So or I can write 5 into 10 to the power minus 5, so kg per meter square, kg meter square, not per kg meter square. Option 1 is a correct one. Clear guys? Understood this part everyone? Any doubts here? Done? Just a minute, let me have some water. Chalo, next. So next question, question number 6. So what's the question says? Chalo. So what's the question says? So 3 particles each of mass m gram are situated at the vertices of the equilateral triangle. So here m mass, and here m mass of side 1 centimeter. Fine, as shown in the figure. The moment of inertia of the system about the line AX. So about this line AX we required perpendicular to AB. So it is perpendicular to AB. So fine. So ABC. So in gram per centimeter square. So in gram per centimeter square units will be. So the simple thing. So about this axis we required. See here. About this axis we required. Yes or no? So the m mass, it is at a distance 0. So the moment of inertia due to this mass will be 0. Right. So now we need the moment of inertia about the x line, which will be equals to, so the moment of inertia due to this mass and the moment of inertia due to this mass. So this mass, what is the mass value? So mass value is, they did not give, m into, so what is the distance here? So the distance is 1 centimeter. L is 1 centimeter. So 1 by 100 whole square. Yes or no? So 1 by 100 whole square. Yes or no? This is 1 centimeter. So I am converting it to meter. In units, centimeters only we required, right? Mass is not given. So m gram. So options are in mass only. Yes, fine, no problem. So m into, so what is the distance? L square. Right? So first let's write the variables, then we'll substitute the values. So what about this mass? So it is at a m, it is at a distance. What is this distance guys? See here. This total length is L. So this is 30 degrees. So then So I can say that this side cos component will come, this side sin component will come. So this is L sin 30, I can write. So plus m into L sin 30 whole square. M into L sin 30 whole square. This distance will be L sin 30. So the moment of inertia due to first mass will be 0. Why? So the R is 0, right? This is the axis. Understanding? So now this is ml square plus, so m into, so this is sin 30 is 1 by 2, so L by 2 whole square. So I can write ml square plus ml square by 4. So which is nothing but 5ml square by 4. So in place of L, if you substitute 1, so then you can simply write it as, already they gave it in terms of L only. So I can write, so 5 by 4 ml square. The moment of inertia about x-axis is, x-axis is 5 ml square by 4. Clear? So if you want to substitute 1 in place of L, you can substitute 1, but options are given in L only, so you can take that. Clear? Simple question that is. So the moment of inertia depends upon, see, the moment of inertia, it always depends upon the axis of rotation, guys. It will not depend on the torque. So generally the torque formula is I alpha. So most of the students think that the moment of inertia is also depending on the torque, and then so here I omega square, L is equals to I omega square, the moment, angular momentum. So the moment of inertia is also depending on the L. So no, don't think like that. P is equals to mv is a linear momentum formula. Is the mass depending on the momentum? Is the mass depending on the momentum? No, right? So the same thing here also. So the moment of inertia will not depend on the angular momentum. So this term will come across later. So just understand the concept. Okay. So it always depends on the axis of rotation only. Okay. So these all options are wrong. Done. Chal. So then let's find the next. So 4 particles of mass m are connected by a massless rods to form a rectangle of sides 2a and 2b side. So the assembly rotates about an axis in the plane of the figure shown. So about this axis, it's getting rotated. Find the moment of inertia about the axis. See here. So what is the mass? So this is of mass m, this is of mass m, and this is of mass m, and this is of mass m. So simply from this axis of rotation, so this will be at a, this mass is at a distance of how much? This mass is at a distance of a, yes. So this mass is at a distance of a because this total distance is 2a, and this mass is at a distance a. This is the your axis of rotation, yes or no? So and this mass is also at a distance a from here to here. So I can write the net moment of inertia about the axis. What is that axis is given? So they did not mention. Let's take it as some x dash. So the moment of inertia about x dash is due to this mass ma square, m into its perpendicular distance. This total is 2a, means this will be a, right? So and then what else? Ma square plus what is due to this mass? Again ma square. So what about due to this mass? Again ma square. And what about due to this mass? Again ma square. So the total moment of inertia will be 4ma square. 4ma square. So option 4 is the correct answer. Clear, guys? Understood? Simple question. So we don't need another slide for this. So let's delete this. Hello. So let's go for the next question, guys. So what's the question says? 4 bodies of masses 5 kg, 2 kg, 3 kg, 4 kg are respectively placed at the position 0, 0, 0, 2, 0, 0, 3, 0, 3, 0, minus 2, minus 2, 0. So the moment of inertia of the system about the x-axis in kg meter square is. So this is the x dash axis. So about this axis, you have to find the moment of inertia. So see, so here the bodies are placed in, the masses are placed in 3-dimensional space because we have x coordinate, y coordinate, z coordinate. So first you need to find, so the distance of a point from each axis. So if you need to find the distance of a point from x-axis, if you need the distance of a point from the x-axis, so then the formula will be square root of, so y square plus z square. Okay, and the distance of a point from y-axis will be square root of x square plus z square. And then the distance of a point from z axis will be square root of x square plus y square. x square plus y square. Clear? Chalo. So now we need about x-axis. So now from x-axis each point will be at a distance of what? So let's calculate that. So for each mass we'll write, so the moment of inertia about x dash. First the 3 kg body. So the 3 kg body into square root of, so what is its y square plus z square? 3 square plus 0 square whole square. Yes or no? M r square. This is r and whole square. Plus the next one 5 kg block. 5 kg. So it is at a distance y is 0, z is 0. 0 square plus 0 square whole square. Plus and 2 kg block is at a distance 0 square plus 0 square again whole square, right? Plus next 4 kg 1 into square root of, so y is 2 square plus z 0 whole square. So I can write 3 into, so here square root of 9 is 3, 3 whole square is again 9, plus the second one 0, the third one 0, plus here 4 into square root of 2 is 2 square is 2, and then 2 square is again 4, so 4 into 4. So it comes out to be 27 plus 0 plus 16, so which is 43. So the total moment of inertia about x dash is 43 kg meter square. Clear? So the correct option is option 1. Understood, guys? Clear? Chalo. So let's take one more question. So let's go for the next question. So 4 bodies of masses 5 kg, 2 kg, 3 kg, 4 kg are placed about the, so first we need about the y axis and then we need about the z axis. So some points are given. So about the x axis and z axis. See. So if you need about first y axis, let's take y dash axis, you take y dash axis. So first let's take 3 kg body. So 3 kg body into square root of, so 0, y means 0 square z square, right? 0 x square z square whole square. X square square root of x square z square whole square. Here x component 0, z component 0. Plus, so in 5 kg block, so square root of again 0 square plus 0 square whole square. Plus, so 2 kg block, so 2 into square root of, so x square 2 square plus z square 0 square whole square. So then 4 kg block, 4 into square root of, so x square minus 2 whole square plus z, so which is 0 square whole square. So I can write, so this is 0, this is 0, this is 0, this is 0. So the first two are 0. Then 2 into, so 2 square 4 plus here 4 into, so minus 2 square is again 4, right? So here 8 plus this one is 16, so which is 24. So the first one 24, it is there in option 2, option 4. You can eliminate these two. So now let's calculate for the z axis. So we need about the z axis, sorry. So z axis, z dash. So first one, what's the first block? 3. So 3 into square root of, so x square plus y square, 0 square plus 3 square, square root of 0 square plus 3 square whole square. Plus next 5 kg. So here for 5 kg, so it's 0 square plus 0 square whole square. And then next 3 kg done, 5 kg done, 2 kg. So 2 square plus 0 square. So 2 into square root of 2 square plus 0 square and then whole square. So plus, so 4 kg block. So x square y square means minus 2 whole square plus 2 whole square. So 4 kg into square root of minus 2 whole square plus 2 square whole square, right? So this is 3 into, so root 3 whole square is 3. Root 3 whole square is 3. 3 square is again 9. So plus the second one 0 and this one 2 into 2 square is 4 plus 4 into, so here it is 2 square 4. So 2 square 4, 4 plus 4 8, root 8 whole square is 8. So I can write, so 27 plus 8 plus 32. So which comes out to be 35 plus 32, which is 67. So the moment of inertia about z axis is, so 67 kg meter square. So 24, 67. Option 2 is the correct one, guys. Understood? So this is about the system of moment of inertia about the system of particles. Understood? Chalo. So let's move further. So let's take the question 11. So what's the question says here? A light rod of length L has two masses M1 and M2 attached to its ends. So let me take, so a light rod, this one. So there are two masses attached to it. So this side the mass M1 and this side the mass M2. So two masses attached. So and the total length of it is how much? L. So then, so the moment of inertia of the rod about an axis perpendicular to the rod and passing through the center of mass. So perpendicular to the rod and passing through the center of mass. Consider this is the center of mass and perpendicular to the rod. So like this. So if this distance is here, we know what is the center of mass distance from the body M1. So it should be the other mass into the total distance by M1 plus M2. And then what is the center of mass distance from here? So we know that the other mass M1 into total distance is L by M1 plus M2. So this we already studied it in the center of mass, right? So simply now you can calculate. So let's consider this axis as some A, B. So the moment of inertia about AB is equals to, so the first body M1 block into, so what is the distance of center of mass? M2L by M1 plus M2 whole square. Plus, so the second block M2 is its mass, and what is the distance of center of mass? M1L by M1 plus M2 whole square. So here I can take, so the moment of inertia about AB will be equals to, so here M1 M2 square L square by M1 plus M2. So plus here M1 plus M2 whole square. So here M2 into M1 square into L square by M1 plus M2 whole square. M1 plus M2 whole square. So IAB is equals to, moment of inertia about AB is equals to, so here in the numerator I can take M1 M2 L square common. M1 M2 is there in both. So and in the denominator you can take M1 plus M2 whole square common. Right? So in the first one, what is left in the numerator? M1 you took it out. So 1 M2 you take it out and 1 M2 will be there and L square is out. Plus in the second one M2 is there. So and M1 1 M1 we took it out. So one more M1 will be there. So that's it. So here 1 M1 plus M2, 1 M1 plus M2 cancel. So the moment of inertia about AB will be M1 M2 by M1 plus M2 into L square. So M1 M2 by M1 plus M2 whole square into L square. Option 2 is the correct one. Clear? Understood, guys? Chalo. So now, so the moment of inertia of the continuous mass distribution. See, if it is a irregular continuous mass distribution, so for this, if you have to find the moment of inertia, what we do is, so we cut it into some different parts. So like, so this is some dm mass, and this is some another dm mass, and this is some another dm mass. So like that, so we cut it into some n number of parts and we find the moment of inertia of each one. So let's suppose, so the moment of inertia due to dm, so the small moment of inertia due to small dm mass is, so di is equals to, so its mass dm into, let's suppose it is at a distance some x, so dm into x square. So then another mass, so let's suppose di, so which is equals to dm into, so let's suppose it is at a distance some y, so y square. So like that, so we calculate all the dm masses and then we integrate it. So the total mass, the total will be equals to, so the integration of dm into, so some particular distance square. So from 0 to something like that, so I is equals to integration of dm into x square, guys. So this is a moment of inertia of the continuous mass distribution. This we already know the process, right? So this x from where to where we take, that depends on the body. What is the body given? Yes, chal. So I'll take the question so that you'll understand better. So let me solve this one. So what's the question says? Find the moment of inertia of the uniform linear rod of mass m and length L about an axis passing through its center of mass. Consider this is a rod of length L and mass m. So its length is L and its mass is m. So now, So we have to find moment of inertia about an axis passing through its center of mass. About an axis passing through its center of mass. So its center of mass is here. So passing through its center of mass like this. Passing through its center of mass, or else let me write this way. So its center of mass. Fine. So first thing is, so let's say we don't know this formula. So actually the students remember its formulas. So let's derive for this. So remaining you can do, you can just remember. So I am taking the very small mass dm. For the linear rod, so the linear mass density will be there, lambda. So the linear mass density is nothing but mass per unit length. So the total mass is m and its total length is L. So linear mass density is mass per unit length. So for this very small part, so let's suppose it is at a distance of some dx. It is at a distance of some dx. So therefore, so the dm m by mass by, so its stored width dx, let's suppose. So its mass is dm and width dx length. So dm by dx, I can take lambda is equals to dm by dx. So now, so this is the origin I am considering. About this axis, now I need the moment of inertia. So what will be the coordinates of this end, guys? This total length is L. So you consider this as the origin, center of mass is the origin. So this side it will be L by 2 comma 0. Yes or no? So then this side it will be minus L by 2 comma 0 because the total length we required. Yes or no? So the total length. So that's why here I am taking it as, so if it is the origin, the total length is L. If it is the origin, from here it is L by 2. So and again from here it is L by 2. As it is to the left hand side, so I am taking it as to the origin it is left side. So minus L by 2 comma 0. So y coordinate is however 0. So the total moment of inertia will be equals to the integration of, so the moment of inertia due to this part and due to this part, due to this part, and similarly we cut this side also, this side one mass, this side one dm mass, this side one dm mass. So like that we cut into n number of dm masses and we find the moment of inertia due to all those small masses and we add it up. So which is nothing but the mathematical tool integration. So the integration of dm into, so let the distance, let it be x square. So from where to where we should integrate this? So the total rod it should cover. So this side to this side. So minus L by 2 to L by 2. Minus L by 2 to L by 2. So I is equals to, so the integration of minus L by 2 to L by 2. So dm. So what is dm? I can write dm is equals to lambda into dx here. So here in place of dm, lambda into dx into the x square. So then I can write, so I, so lambda, take it out. So from here, so the x square integration is x cube by 3. So from where to where? L minus L by 2 to L by 2. So I is equals to, so lambda into, so I can write, so x cube by 3 minus L by 2 to L by 2. So let's take this 3 as also out. So I is equals to, the total momentum is equal, moment of inertia is equals to, so here L by 2 whole cube minus of, minus L by 2 whole cube, I am writing it as plus. So L by 2 whole cube again, because minus, if you take it out, minus of minus will become plus, right? Upper limit minus lower limit. In the lower limit minus is there. If you take it out, minus of minus plus it will be. Yes. So here lambda by 3 into, so here L cube by 8 plus L cube by 8. So which is nothing but lambda by 3 into 2L cube by 8, right? So from here 2 1s are 2 4s are, right? So here in place of lambda I am writing m by L into 3. So here L cube by 4. So which is nothing but ml cube by, sorry, so L gets cancelled, ml square by, so 3 into 4 12. So therefore the moment of inertia due to a rod, so through its center of mass, will be equals to ml square by 12. So this is a standard result, everyone should remember. So the moment of inertia of a uniform linear rod, so about its axis which is passing through the center of mass, is equals to ml square by 12. ml square by 12. Clear, guys? Chalo. So then if you want to find for the ring, so you can directly remember the formula. So for the ring, so if it is a ring, So for the ring, so the moment of inertia about an axis passing through its center like this, passing through its center and perpendicular to the plane of the disk. So passing through its center perpendicular to the plane of the disk. So it's going to be the radius r. So the moment of inertia will be mr square. Moment of inertia will be mr square due to the circular ring, uniform circular ring whose mass is m and whose radius is r. Clear? Just remember that formula. So then, so the theorem of parallel axis. See, so the parallel axis theorem has to be applied when, so if you know the center of mass about, if you know the moment of inertia about the center of mass of a body, and if you want to find the center of mass about an axis which is parallel to its center of mass, just understand carefully. You already know the moment of inertia about the center of mass of the body, and now you would like to find the moment of inertia about an axis which is parallel to the center of mass axis. Okay, so about this axis now you have to find the moment of inertia. So about x dash you have to find. So we already know about its center of mass. This is a center of mass axis. So then the moment of inertia about its center of mass plus, so let the body's mass be m. So consider this distance is a, and so m into a square. So this is a formula you should remember, guys. So the parallel axis theorem can be applied for 1D objects, can be applied for 2D objects, can be applied for the 3D objects. Okay, so but when to apply? If you already know the body's center of mass, a body's moment of inertia about its center of mass axis, then if you have to find the moment of inertia about an axis which is parallel to the axis through center of mass. So about this axis you have to find which is parallel to this axis which is passing through the center of mass of the body. So then you can apply the parallel axis theorem. I x dash is equals to I center of mass plus ma square. Clear, guys? So I'll take one question so that you'll understand better. So let's find moment of inertia about the axis as shown in the figure. So this is a uniform rod of mass m and length l. So now I need to find the moment of inertia about, so end. Okay, so about n, let's consider this is x dash. So if this total length is l, this length will be, center of mass will be at a distance of l by 2 for the uniform rod of length l. We already derived that in the center of mass, right? So then the moment of inertia about center of mass x dash. So now apply the parallel axis theorem. So the moment of inertia about its center of mass of the rod plus, so the total mass mass of the rod is m into, so at what distance you are finding from this axis? L by 2. So L by 2 whole square. So from here this we already know, m L square by 12 plus, so this is m L square by 4. So here 12 is the LCM. So m L square plus, so this is 3 times, so 3 m L square, so which is 4 m L square by 12, so which is nothing but, so m L square by 3, m L square by 3. So this is the moment of inertia about x dash axis, m L square by 3. So this also you remember it as a standard result, so standard formula. So that means for the uniform rod of length l and mass m, so the moment of inertia about its center of mass is ml square by 12, and the moment of inertia about its one of the end is equals to ml square by 3. Clear, guys? Sure. So let's take this question. So the 15th question for today's session. The moment of inertia of a thin uniform rod of mass m and length l passing about an axis passing through its midpoint and perpendicular to its length is I naught. So its moment of inertia about an axis passing through one of its ends and perpendicular to its length is. So just now we have seen the same question. Here the moment of inertia about the center of mass is given. So the moment of inertia about center of mass is I is equals to I naught. So now we have to find its moment of inertia about an axis passing through one of its ends, passing through one of its ends. Let this end, axis be x dash. So and perpendicular to its length is perpendicular to its length. See here, this axis is perpendicular to its length. So we can write like, so the moment of inertia about x dash is So moment of inertia about its center of mass plus, so this will be at a distance L by 2, yes or no, edge from center of mass to edge L by 2. So m into L by 2 whole square. So about center of mass they said I naught. So I naught plus ml square by 4. Don't take the formula here because they said clearly I naught, and in the options also they gave in terms of I naught. So it will be I naught plus ml square by 4. Option 2 is the correct one, guys. Clear? So this question you take it as a homework. So just one question for the homework. So take this as a homework, guys. Right? So chalo. So that's it from my end. So this is the lecture number 3 of rotation chapter. So in the next session, so we'll discuss about the different bodies like a disc, circular ring, about its axis, and about its center of mass. So about different axes, cone, all these things we are going to discuss in the next session. So till then, keep studying. All the very best. Bye, guys.